And for our last spotlight team, I want to bring on Herman to tell you about Ethereum Virtual Virtual Machines. Please give him a big round of applause.
Thank you, Kartik. Okay, hello. I'm Herman. I'm the CEO of the EVVM. There is the CTO over there, that is Kevin, and the CMO Victor. So we are three of the team here right now. We came from Latin America, so it was a long trip. Nice to see you all here. So EVVM, what is it? It's secure and easy virtual blockchains. So what are you looking for? We are giving a solution to deploy customized virtual blockchains ready to use on top of any blockchain. So there is a host blockchain that is an EVM, could be maybe Ethereum mainnet. And with this solution, you deploy using smart contracts a new abstracted layer with all customization by you, maybe in a few minutes on top of it. So what is this? It's easy for developers. It's very simple to customize. It's one command deployment. We have already made an extensive dev tooling. There is UA libraries to implement in your dApps. We have workshops. There is a complete documentation that you can see at evvvm.info. It's open source and very interesting. It's upgradeable. So if next versions comes, you can continue upgrading your virtual EVM. So some improvements that can be made on a EVVM. We have like trusted execution environment relayers. This is very interesting for DeFi and adding privacy layer to and doing some sharding also on your virtual layer. We have a name service that is full on chain. There is staking, reward tokenomics, stablecoin lending is already developed, and some functions that are very interesting that we think are improvements from EVM that are very easy to use and to make also new ones on the EVVM because everything is coded on Solidity. This is very interesting. Is that you can have token whitelisting, you can have native tokens, you can have synchronic and asynchronous nonces, you can have executors, you can do dispersed transactions natively, and you can use emails and phones as native IDs on the transactions on chain. So how it works, make it as open as you need. You are deploying a private EVM environment on an EVM. So you can use, in example, a layer 2, Arbitrum, a layer 1, Ethereum mainnet, and you will have this deployment that will behave like an EVM naturally, but you put there your rules. So to go from your EVVM to the host EVM is a demilitarized zone, so you go wherever you want. You have full connection, as any smart contract has. But to go inside, you will have an interface that you can set limits, you can set permissions, who can access to different parts, some functions, etc., some virtual opcodes, abstracted opcodes. So also for external transactions, you can block some, and you can have permission on some. So you will have your virtual blockchain on the blockchain. It's important to note that we are using the consensus and the execution on the host. We are abstracting the state. The state is ours on the host, but we have our state there. And you can do also an abstraction of executor layer if you want to use relayers or other actors. So you have your EVVM on the EVM ecosystem. It can interact with all the tokens, smart contracts that are on the EVM, but you can do synthetics from them when you go through a component that is a treasury. And also you have access to all the protocols that are connected natively in the host EVM, plus everything that you want to connect using, in example, relayers or whatever. So the virtual blockchain components, there is an EVVM core, that is the main component where the state is, and you can do there a lot of configurations and modifications there. You have a treasury. This can be on the same chain or can be in a different chain. So you can deploy a treasury maybe on mainnet, and you will have your EVVM core on Arbitrum. And you connect them directly, but you have for DeFi purposes or security purposes, your core component in another chain. There is native token, account states, relayers, and services. So the EVVM core, the process to have a transaction, the process is divided in 3 stages: transaction creating and signing. So every transaction is like an intent or a meta transaction that inside the metadata is the transaction itself. So here is a schema and how it's validated. Then you can use fishers, because we call them fishers because it's the relayers, but you can use them to fish, to capture transactions, maybe in other mempools, maybe with APIs, maybe through an email, maybe through an SMS message. So it's like we call that also phishing spots. And well, through this, the fishers or the relay will validate the transactions, and then will finally execute it on the chain. If the transaction is not valid, the fisher or the relayer has no reason to do that, so it will be reversed. And the execution and rewards is part of this also. So here,
To verify a signature is so simple. In this example, we're going to use pay-no-staker async function. So, the fisher sends the inputs plus the signature inside the function. After that, the verification begins. So, they use signature utils verify message signal for pay. This is composed an string concat of all the inputs plus the function signature and compare it to the signature. If it's correct, the function continues. If not, reverse the transaction.
okay, you have the full repo available also to check all the code and the documentation again at evvvm.info. So also there is another component that is the native tokens that are not mandatory, but is recommended to use a native token, not synthetic, for utility. You can maybe make it useful for the EVVM functions. You can have it also for rewards. It's already coded. So you can give benefits to the actors that are supporting the protocol to a better tokenomics and incentives, like give it to the relayers or to the people that is having good behavior. So later, and is securing the virtual blockchain. So later you can share with them some yield from the synthetics that you are staking somewhere else, or doing, or like using DeFi protocols to generate something. And of course for access control, so maybe you can gate token some functionalities, or well, we already do that also, so this is optional, but it's very interesting.
In this example, we can see if the executor is a staker. If it is, continues the transaction. If not, revert the transaction. After verification, the executor receives a reward for process that transaction. Also, the staker receives yield by epochs.
An example of how the estimator works. The estimator is the contract that is giving the rewards to the stakers, is fully calculated on chain. It's about 60K lines of solidity, the whole solution. We are just showing that it's very easy to configure, to use, to modify, because it's on solidity. So there is also another component that is the account state. To avoid double spending, a nonce is always needed. But here is something interesting. We have sync nonces, is the standard, but we think Ethereum needs something that is async nonces, and we can very easily implement it on the EVVM. So you can use async nonces when I need something right now. There is some transactions mine in the queue, so I send an async transaction and will be executed now. There is the opposite. I don't care about this. Charge me later because it's your priority. I'm paying some insurance or something, and of course the company will execute it on my behalf, and it's possible. And trigger execution, in example, DeFi orders, I just send a transaction that will be triggered by some smart contract, by some rules. I cannot be triggered by someone else using the executor function, so this will work also.
We have two types of nonces, sync nonces and async nonces. The key characteristic of sync nonces is that the sync nonces has sequential incrementing. Each successful transaction increases the nonce value by exactly 1 unit. And The key characteristic of async nonces is non-sequential. Numbers don't need to follow any particular order or sequence. And we have executor. This function characteristic is that a certain address can execute this transaction. Think it like a voucher. This voucher can be redeemed only by a specified address.
Okay, and then we also have a name service, very interesting. You can use emails, you can use phones natively on the transactions, writing an email on a transaction in place of an address on chain and will be resolved the same with a name. We have also a schema of metadata that you can add on chain for these names, and demand-based renewal fees proposed by Vitalik is something very interesting. So our renewal will be based in the highest offer that we get for the domain through a staking with a max cap. And this will solve cyber squatting, but also people will start using all their domain names. And it's fully on chain. I will skip this video because I'm taking too much time. So we are working on banking solutions using trusted execution environments for obfuscation and privacy. Through the banks can go into the DeFi, and then they are configuring access also for any user. So the users can go interact into the banking DeFi ecosystems with or without being customers of them. And the banks can also transact with privacy, banks or institutions on the same pools or on the same DeFi protocols through these interfaces. We also worked with Abal through a grant that we got, and we have ready this to publish this service. When we go to mainnet, we are on Testnet now also. If you go to evvm.org, you can join the waitlist to get access to the testnet. So there is Go liquidity providers, there is a lending service that is working with Go, and then everything that is locked there is going through to Aave to generate yield, and then this is spread among the actors that are helping on this. And okay, some EVVM use cases, valuable integrations that we are waiting to see, banking, DeFi, gaming, art, social, and we are developing the zk-EVVM for the future. On the end of this year, we will have a proof of concept version. So please stay connected, and thank you so much.